Okay. So, good evening, everyone. Today, we'll have a talk about Java 8 Stream APIs. So, the Stream APIs are something like related to pipeline, but not the elements. They do not store any elements. They do not have any objects. They are just a pipeline or the API which are used to connect from one interface to another interface. So they conveys the elements like whatever elements we have from a source to the computational operation. So this like data structures or arrays or channels or whatever we have through a pipeline, they connect from one source to the other target, whatever is required. And the stream is a functional, it's functional in nature, and operations performed on the stream, it will not modify anything in the source. They just connect with the source and get the data to the target, but they don't have any, they don't modify any data. So, if like if we are filtering a stream obtained from a collection, so when that filtration is happening, they don't remove or delete or update the data. They just filter the data and take out the data whatever is needed. So this stream is completely like it evaluates the code only when it is required. So when we are calling the stream, then only this evaluation is done, but the modifications will not happen. And the elements of the stream are visited only once when we call the stream. They are not like an iterator or any for loop. They don't go on touching the objects, or they don't visit the same elements of the source again and again. In coming to our Java stream methods, we have different types of methods through calling or some through calling these pipelines. So we have several type of method, and they have their own description path. Like while you use them, you can understand what exactly matches and what exactly is required, whether we are matching or we are collecting or we are mapping. Whatever functional is needed, according to that, we use this methods to be called, and then we put them directly. So if I just say this is all about the streaming part of the Java 8. Apart from the streaming part, we have the collections, and then we have the methods. We can actually sort the data using the streams. We can directly use them into a reference, and then we can give this complete set of data directly into the uh, coding to get the reference whatever is needed. So the next part is the optional class. So optional is is like a container object which is used to contain the not null object. So if we have any not null objects which are not empty, those objects are only used in this container. And this optional object is used to represent null with the absent value. It won't give you the null values. It just say whether they are available or not available. So this class majorly handles the values which are available but not available, instead of checking null values. So if you say there this object available, then it says available or not available. That's it. We don't deal with the null objects. So for getting this class, you have to declare your Java utility dot optional to get this class, and then you can directly use this class named as optional, which extends to your object. So here also you have different types of methods where you can actually call the classes and then have their functional values. So you have boolean equals, which equals the values to one another, and you have t get values, you have hash code values, you have else values, tls values, string to string values. Such type of methods are there where you can actually use them directly in your Java 8 to have this setup, and then I mean, you can use this optional classes directly, and then get your answer or requirement, whatever is needed. So the next topic is the collector class. Collector class is also an object, but here you have the complete collector bot. So in this collector classes, these are the extensions of these object classes. It provides a reduction operations such as accumulating elements into collections, summarizing them, like getting them onto the set. And here also you have different types of methods wherever you have, I mean, whatever you have learned for strings and all, same types of methods also will be used here. And if we just see what is this static keywords, default methods, these are also similar to our methods which we have it in Java. So they don't have much differences between them, but they are actually similar to our Java itself. So this is actually all about our Java 8. So majorly, I'm not getting into deep concepts of this Java 8 because, as you all know, we don't use it majorly in our projects, and whatever the concepts we learned for our Java, basically they get into our main thing. So we don't have much things for this. Now coming to our programming part. So yesterday we have learned about the palindrome, string palindrome. I asked you to go for int palindrome. Have you tried it?
Forgot,
Have you
madam.
tried it, guys? Yes, Tarun.
No, madam. No, madam. Forgot.
Okay, just go and practice that for today. Today we will go with the Armstrong number. So, what is an Armstrong number? So,
Don't know.
Armstrong number, yeah.
Don't know. That was I'm saying. Don't know.
Oh, okay. So Armstrong number is something like, see, there is a number, and if you have to divide the number into individual parts, and then each number's cube and sum of all those cubes will give you the number again. So the best example is 153. 153, if you do it like 1 cube plus 5 cube plus 3 cube, that is 1 plus 125 plus 27 will give you the value as 153. If this happens, then only it is known as Armstrong number. Okay, you understood the logic, right?
Yes.
Hmm. So now we'll try to write the code for that. Just a second. I'm trying to open the compiler. It is not opening. Okay. So I've imported my util, and then you in my main method, I'll declare input, and then I have to have my scanner, and then after my scanner, I'll try to have my input. I'll take my input, and this will be saved in my scanner. Okay, so till here it is common, and now I'll print whether this is Armstrong or not. This will be as my input. Now I have to write a method. So now I will have the values like first I will have an int value, some a. What does this a does is a will store this in value because I will change the a but not in. So I will go on changing the a. So now I will enter into a loop, and it will be greater than 0. We'll decide whether about the condition later. First, we will try to get the values. So now I have the digits. Or let it be 3 digits or two digits. What will I have to do? First, I have to percentile 10 and take the remainder. So my A will be in percentile 10, which gives me the last digit, right? So it gives me the last digit. See, if it is 12 divided by 10, I will get it as 2. Then I have to take a sum, that is, I have to take a total, which is like tot is equals to, okay, I will initiate is equal to 0 first. So tot is equals to tot plus power. I have to use the power. So I use my math command in which I have the power as my power value. A. Okay, so this does my total and the power. So for the first value, 2 cube will be taken and it is stored in total. And we will print the total also to understand. And then, and okay, if I take it as, no, if I take my input, okay, let it be. So I will do in divided by, in is equal to in divided by 10. So if it is 153 divided by 10 will be 15. So in will have the value as 15. And then when the loop is going on again, 15 percentile 10, that is 5. This takes as 5 cube. For the first time, I got it as 3 cube. For the second time, 5 cube. And then the remaining 15 divided by 10 will be given the value as 1. So A will be having 1 percentile 1, that is 1 cube. Yeah, okay, done. And after all this, and this will be in. So I have to see that 1 divided by 10, I mean 1 divided by 10 will be 0. So when it goes to 0. When you there will be no number. So it has to be in itself. And now I say if my total, okay. So if I change my in, then the number also will be changed. So what I'll do is I'll take out another value b, and this also will be equal to n. So as I'm using my in, I have to check verify whether it is equals to b or not. If it is, then return true, else false. Okay. I hope you understood while I'm writing the program itself. So here I have taken the percentile 10. When I'm running this, you will understand what exactly the values are taking up and giving out. Okay. Method power in class math cannot be applied to given types. Okay, why like that? Okay. So power value need to have two inputs. So while n is greater than 0, I will need to have the count of my digits. How many digits and the power of those digits will give me the value. So it gives me the first value, the second value, till it gets, and the digits will be counted as. Yeah. Okay. So when we have given the number, it goes into our first while loop and it calculates a digit. So for the power function, if you just see, the power function takes the two inputs, which is like the number of the value and the number of digits till where it has to count. That is like, if it is, so power of 1 to the power of 1, 1 to the power of 3, like that. Okay. So this digit we have calculated in this while loop, and while coming to our main loop, so we have done 153 percentile 10, which gives us a value as 3, and then that is stored in A. And when we are doing a value of A, then A cube, that is 3 cube, which gives us the values of 27, and whatever the leftover is 15. So when it 15 is taken, and then it is taken into the loop, again you will have 5 as your percentile value, and then digit 5 cube. Mhm. So 5 cube, and then it is added to 27, which gives us the value as 152 here. And then that value is actually stored in our I mean, that value stored in tot, which is like 152, and the last value which is remained is 1. So 1 percentile 10 again will give you a whole value as 153. So after 152, you got it as 153. So 153, and then you're returning it. I mean, after 153, it becomes 0. So if it is 0, 0%, I mean, 0 greater than 0 is not true. That is why it comes out of the loop. And then we go into our if condition and see it is whether true or false. Then it gives us the value. If say, if you are giving the value as a number which is not a Armstrong number, then it says false. Okay. Any doubts? Hope you understood this program. Yes, guys.
Madam, once explain, madam.
Uh, can you just explain from your end?
Sorry, madam.
You explain me. I'll let you know if you're going wrong.
Okay, madam. Then from the beginning onwards, madam. Scroll up.
Okay. Are you explaining me or should I go ahead?
You just say, madam, because I know only up to half part. From
Yeah,
there, I
this
don't.
you know, this you understood, right? So here I am calling this method is Armstrong method and throwing my input as my input. So it goes to this method. And in this method, I'm writing the logic. It says, see, the logic is like 153. If the number is 153, then I have to take 1 cube plus 5 cube plus 3 cube. To take that value, I will first take up my so for that, first I have to take up my power function, which is a specific function. So if you learn about this power function, you have to have the two values, which is like last digit, what is the digit of it, and then how much time of it has to be powered. So this is what is taken in this power value. So for that, I have to count my digit value, which I'll be taking it as like I have to count the number of digits. So it says if you just system output here, you will get the value as 3. So the digits are three here because the input is 153. 153 divided by 10, it gives 15 first, and then it goes into the loop. It gives 1, and then after that it goes with a 0. So it is like 3 times this loop is going on. So digit plus plus will go with the 3 values. So after that, when I'm entering into the second while loop, it says A in percentile 10. So in percentile 10 is my input. Input is 153. So 153 percentile 10 will gives me the value of 3. So the a value will be 3. Okay. And then I have initialized the power of a. So a cube, that is 3 cube, that is 27. So for the first time, the tot which is taken as 0 here, we have assigned it as 0. So 0 plus 27 will be equal to 27. So tot is taking the value of 27. And the next point, when I'm taking my in value, which is divided by 10, so I will get 153 divided by 10, which is only 15. So in is stored as 15. Now for that 15, I have to go through the whole process, in which now tot is already having 27 value. It will be sum up with 5 cube, that is 125. So 125 plus 127, which is 152. And in this tot, the value will be stored as 152. Now you got it? Okay. So this is about the Armstrong number. So we will go with the other program also. So as I said, we will have a program where it gives us a deadlock program. That is thread. There is a thread which is going on. It gives us some value if it is holding, and it wants the object to value also. And so how this two methods will be fighting for the values itself. It goes on circulating in the same method, in the same program, but it never comes out of the program. So it's like a circular task. So do you want to go for that topic and understand, or shall we go for a simple program now? Okay, we'll do the deadlock program tomorrow. Today we'll go for the factorial program on the same program, so that we can actually write it fast. Okay, I have to enter the number for factorial. So you will take a number, and then you will call the factorial program. So this is my program. I mean, this is my method. In that method, I have to write my factorial program. So int a, which will be first be initialized 1 itself, because factorial is what, guys? So if you want a factorial of 6, then you have to do 1 into 2 into 3 into 4 into 5 into 6. So that will give you the value of factorial of 6. So for that, I will use my while loop. While some in my in value should not be equal to 0, and then I have enter into my loop, and in that loop I will write my total. This I'll take it as a total to understand. So my total would be tot into in. So 1 into in, and then I will do in minus. So it is like first I will get 1 into 6 and then in minus minus. So then I'll get 5. Like 1 into 6 is 6, 6 into 5 again 4, 5 into 4 again in minus is 3. So again I'll get 4 in whatever the value into 3, then 3 minus minus 2, so it goes with the 2, and then again 1 again into 1, and then minus minus 0, which is not equal to 0, so this comes out. Is this clear? Arun, did you understand this part, factorial part?
Yes, madam.
Yeah, it is
Madam,
very
that
simple.
in value we are giving the input value, madam.
Yeah,
That
this
I
is my
get.
input value. So input
Okay,
is
here,
my
madam.
input which I am taking from the from my system.
And
So this input will enter into this method, and in value is already stored as 6 or 7, whatever we give, and with that I'm going with the values. Okay.
okay,
So if you want, we'll try to put down or system out so that you will understand what this is holding and what that is holding. I'll do one thing. I'll write a system dot out dot println. I'll print in value here. Okay. So this value, whatever I'm getting it here, will be printed first, and then we'll print a system out here, which prints my total. Okay. And then we'll have a print here also, which prints my in. So this would be my 1. This would be my 2, 3. Okay. So we will understand whatever what values are coming and all. Actually, I need to have another thing. Okay. In this main method, and this is my method, and in my while loop. Okay. So here we have taken it as boolean, right? So I have to give a return value if it is a boolean. So instead of that, but here I have to get the value as some number, into some number, 1 into 2 into 3 into whatever the number I'm getting, I have to get it here. So the return type will be my int, and then I will return my value. What is that value? Tot. Okay. So I will return my tot. So the tot, whatever value I'm getting, it will be printed as my output here. Factorial of input, whatever I am pulling out. So it prints my tot value. Okay. So after getting into that, so my first output is 1 in. So whatever input I'm sending it from my method, it takes it. So that is 6. And then for the first time when it enters into the while loop, it prints my the second system is 2 of tot, which is 6. 1 is 6 and 2 is 6. And my third output, which is minus minus, so 6 minus minus, which gives me 5. So the third output is 5. So again, it goes back to the while loop and it checks whether 5 is not equal to 0, true. So it goes into the loop and it says tot is equal to tot into n. What is my tot? So tot is 2, right? So 6, the value is 6. 6 into my in value became 5. So 6 into 5, it gives my value as 30. So the tot will be 30. And then it becomes in minus. So in is 5. So 5 minus minus is 4. So my in value is 4. And then it goes back to the while loop again, checks 4 not equal to 0, true. So it gets into the logic, multiplies and says 2, which is a tot, which is 120. So the tot goes on multiplying the minus minus of numbers like 5, 4, 3, 2, and then 1, and last make became 0. So when it went back to the while loop, it says 0 not equal to 0, which is a false. So it comes out of the while loop and it returns this dot, and the return value, whatever we are returning, it gets captured here in this format. So that is where this complete system, I mean this complete outline will be printed. It says factorial of 6 is 720. Okay. Any doubts? Any doubts in this program?
No.
Okay. So this is another simple program you can actually practice. So along with this program, try practicing the integer palindrome also. Okay. So this is for today. Maybe we are good to end the class now. Tomorrow, before starting the others type, like now we have done with our Java 8 also, we'll go with advanced Java. But before going into the advanced Java, we will try to complete some more programs in the class. And maybe by Monday, we'll start out with the advanced Java. Okay. So for advanced Java, I'll try to prepare a PPT so that even if it is a theory part, you will get on to the understanding more. If it is a PPT, it would be interesting for you. Okay. Thank you, everyone. Thank you for attending the class.